we'll look at linear equations. We'll see as to get into the start with the basics, right? So what are the basics of a linear equation? I mean, equation is anything which is going to have an equal to symbol over there, right? A linear equation is where the power of the variables is going to be one, right? A simple one variable equation is something like 6a equals, let's say, 8, and then we can write a equals 8 by 6 or 4 by 3 and solve for it. So if you have one equation and just one variable, we can definitely solve for it. If you're going to have more variables, right? So how many equations are required to solve for it, and so on and so forth, we'll look at shortly, right? So when they are going to be solvable, as simple as that. I mean, if you're going to have n equations and all of them are going to be consistent and independent, right? Consistent and independent. We'll look at that as well, right? So sorry about the handwriting. Yeah. So n equations and you have n variables, and these equations are all going to be consistent and independent. You can definitely solve for your n variables over here, right? So that's the basics, right? So when it comes to linear equations. Now, linear equations on a graph, right? How is that going to look? And what are the linear equations which we'll be able to plot on a graph? Now, these equations are going to be such that you're going to be having two variables, right? So two variables. You can write something like x plus 2y equals 3, for instance. The way we plot it in a graph, and some of you would want to plot it and solve it as well. It's not going to be too difficult. There's also the basics of coordinate geometry, 2D coordinate, which we have as well, right? It is to express this in the format of y equals mx plus c, right? So y equals, if you move x to the other side, you're going to get minus x plus 3, and you bring the 2 down, right? So it's minus x by 2 plus 3 by 2, right? So we'll get into it more in depth in the coordinate lesson, right? But from the perspective of linear, for us to understand this, the way it's going to be is we're going to have um, the m, or the slope over here, is minus half. Anything negatively sloped is going to be like this, right? From top left to bottom right. Anything which is growing, which is positively sloped, is going to be this way. The coefficient of x in this format is going to tell us the slope. Now the slope over here is minus half. When would it be? When would it be at 45-degree mark? When it is minus 1, right? It will be at 45-degree mark. Anything where it's going to be the absolute value is less than 1, right? Then it's going to be flatter. We know it's going to be flatter. But what is this plus 3 by 2 telling me? This plus 3 by 2 or plus 1.5 is telling me where it's going to be cutting the y-axis, right? So this over here is going to be 1.5, right? And yeah, so this is the line we're going to be getting over here. Minus half the slope tells me, right? That is going to be a little flatter. More into these details in the coordinate lesson. But essentially, when will the lines be solvable, right? So which we looked at earlier as well. So if you're going to be having another line which is parallel to this, it won't be solvable, right? So if you're going to be having an overlapping line, it won't be solvable. But if you're going to have any line which is going to be uh, of different slope, right, of different slope over here, it will definitely be cutting this other line, intersecting the other line at exactly one point, and that is going to be the solution xy points for both these lines, right? That's from a graph perspective, linear equations. If you have two equations, you should be able to, I mean, with two variables, and both of them are independent and consistent. This is what it means. Both are independent and consistent. Then you're going to be getting one solution, right? So positive, negative sloped is going to be coming from the coefficient of x in this form. If this would have been positive, it's going to be the other way around. And when is it going to be? When it's going to be parallel to the x-axis or y-axis, right? So how is that going to look, and what is going to be the equation? So if it's going to be parallel to the x-axis, it is always going to pass through one y value. So let's say that y value is going to be 2, and the simple equation of this line is equal to y equals 2. Now let us say some line is going to be parallel to the y-axis, then it's cutting the x-axis only at one point, which means across this line, we're going to have an x value of minus 3, let's say. This is the point at which it's cutting, right? So the equation of the line itself becomes x equals minus 3. Equation of this line itself becomes y equals 2, right? Where could this be used? More in the case of inequalities. you could be given something like, mod of y is less than 2, right? So modulus of y over here is less than 2. Then we'll have to be drawing one more line over here, and this entire region over here is the mod y is less than 2, right? So we look at that in depth and inequalities. At this stage, y equals 2 means it's going to be passing through 2, right, on the y-axis always. So draw a line which is parallel to x-axis, the other way around. If x is minus 3, passing through minus 3 on the x-axis, but parallel to the y-axis, you got to draw, right? So it's going to be perpendicular to the x-axis. Look at it that way. Okay, so that's when it comes to the linear equations on a graph. Moving to the next one, what are these dependent and inconsistent equations, right? And then we'll take up a small example over here. So dependent and inconsistent equations are going to be those where we're going to be having lines which are going to be either overlapping or they are going to be parallel lines, right? From a graph perspective. So let's draw the graph as well. So let us say we have a line over, we have an equation over here. If I'm going to be having another equation which is going to be overlapping it, it simply means the equations are one and the same. So those are called dependent equations. How do we create them? If 2x plus 3y equals 5, and I have another equation which is 4x plus 6y equals 10, right? So what is happening over here is I'm just multiplying this with 2, and I'm getting the second equation. The second equation is dependent on the first one. So if you have two equations which are dependent, you won't be able to solve for it, right? You're going to be having overlapping lines. There are infinite solutions. Every point on these lines are solutions because they're lying on both lines, right? So infinite solutions over here. When does this happen? When we have a1 by a2 equals b1 by b2 equals c1 by c2, right? Now, what are these a1, b1 and all of that? That is, if the equations are going to be a1x plus b1y plus c1 equals 0. C1 you can take it to the other side as well, like we've written, doesn't make a difference. A2x plus b2y plus c2 equals 0. These are the two linear equations over here. If if the ratio of the x coefficients equals the ratio of the y coefficients equals the ratio of the constants, then yes, infinite solutions. When is it inconsistent? What happens in inconsistent solutions over here, right? Under the same scenario, if we're going to have no solutions over here, and what happens over here? And this is when a1 by a2 equals b1 by b2, which means if the ratio of the x coefficients and y coefficients are the same, that means the slope is the same. If the slope is the same, it's going to be parallel to it, but it's going to be a little away from it, right? It's going to be a little away from it, which means the ratio of the constants is going to be different. C1 by C2 over here is not going to be equal to these, right? You need to remember this part. And how do I create inconsistent equations? The simplest thing for me to create 2x plus 3y equals 5. And if I double it, I'm going to get 4x plus 6y, but I will write 9, right? I will write 9 over here instead of 10. Then I'm going to get two parallel lines, right? 2 by 4 is 1 by 2. 3 by 6 is also 1 by 2. Both of them are equal. 1 by 2 equals 1 by 2, but it's not equal to the ratio of the constants. That's 5 by 9, right? Then they're inconsistent. There are no solutions. How do I prove that? Multiply this with 2, top minus bottom. We're going to get, we just multiply this with 2 and let's write it down over here. 4x plus 6y equals 10, right? If I'm going to multiply this with 2 and write it here. Now, if I subtract the 2, 4x and 4x are cancelled, 6y and 6y are cancelled. I'm getting 0 equals 9 minus 10 minus 1. How is that possible? That's never possible. So no solutions over here. So when does this arise? A1 by A2 equals B1 by B2 is not equal to C1 by C2. Now, what are these equations which are solvable, right? Whatever is not dependent, that means you have to be independent. And whatever is not inconsistent, that means you are consistent. So when do you become solvable? When your slopes are going to be different. That means if A1 by A2 is not equal to B1 by B2, that's it. It's definitely solvable. I don't care about the constants, whether it's equal to C1 by C2 or not equal to, doesn't matter. The moment A1 by A2 is not equal to B1 by B2, it's 100% solvable. The ratio of x coefficients is not equal to ratio of y coefficients. You can do that. Your infinite or no solutions arise only when there is an equality between the ratio of the coefficients of x and y, right? So that's from a simple linear equation perspective, right? So let's take up an example over here, and let's see as to how to do that, all right? So this is something which turned up in the CAT 2020 paper. Let k be a constant. The equations kx plus y equals 3 and 4x plus ky equals 4 have a unique solution. That means there is one solution over there. That means they have to be independent and consistent, right? So they will have a unique solution if and only if when a1 by a2, right? Let me write this clearly. A1 by a2 is not equal to b1 by b2. That's it. When is that going to happen? K by 4, right? That's the ratio of the x coefficients. K by 4 is not equal to 1 by k. 1 by k. Okay. So then cross multiply. K square is not equal to 4. So k over here is not equal to root of 4. And what is the root of 4? Plus or minus 2. K should not be equal to plus 2 or minus 2, right? So therefore, k is not equal to 2 is partially covering it. But modulus of k is not equal to 2 is what is fully covering it. Because if I put a plus 2, it satisfies. Minus 2 also, it satisfies. It should not be equal to it. So therefore, modulus of k is not equal to 2 is the correct answer over here. This is only partially satisfying. Next concept over here. So the concept 4 over here is about solving equations, right? There are again several ways to do it. You can substitute, you could subtract, you could divide. All of these are possible, right? So let's just take up two equations. 2x plus 3y equals, let's create one, right? If x is 1 and y is 2, what is that going to be? That's going to be 8. And you have 4x minus y equals, it's going to be 2 over here, right? So how do we solve for this? When it comes to substitute, I mean, let's start with subtraction. That's the one which you're going to be using more often, right? So what's that going to be? So multiply this with 3, and if you add them up, right? If you're going to be adding the two up, right? So what's going to happen? Your plus 3y and minus 3y are going to get cancelled. So what do we do with subtraction over here? We're going to be multiplying one of these equations with something or both of them, and we add or subtract so that one of the variables is eliminated, right? And we're left with one equation with one variable, and we solve for it. So if you're going to be adding these two, your 3y minus 3y get cancelled, you get 0. 2x plus 12x is going to give us 14x equals 8 plus 6, which is 14, and you get x equals 1. The moment you get x equals 1, you substitute into one of them. The first one, let's say, we're going to be getting 2 plus 3y equals 8, and 3y equals 6, and y equals 2. And you solve for both, right? So that's subtraction. Subtraction or addition, it depends on it. And substitution, what is that going to be? Right, so substitution is where we take one of them, let's say the same one. If 4x minus y equals 2, then y equals 4x minus 2. And this I'm going to substitute into the first equation over here. So which is 2x plus 3 into 4x minus 2 equals 8. And so 2x plus 12x is 14x. Minus 6 over here, you take it to that side, becomes a plus 6. 8 plus 6 is 14. Skipping some steps over here, you get x equals 1. The moment you have x equals 1, plug it into this, and you're going to get y equals 4 into 1, 4 minus 2, which is 2. So y equals 2. We get the same set of values over here, right? So the third type is going to be slightly less common, but when it turns up, it turns up. And it could be used to solve a lot of questions under like time and speed and other places, right, where division is used, right? Because you have something like distance equals, the speed equals distance by time and so on and so forth. So division comes in handy as well, right? So how do we create a question around that? I mean, 4x plus 3 by y equals 5, say, and 3x plus 2 by y equals 7, right? So how do you solve for that? Divide the two. The moment you divide the two, you're going to get something like 4x plus 3 divided by 3x plus 2 equals 5 by 7, and cross multiply and solve for one variable, substitute it back and find the other, right? So that's division over here. So let's look into example straight, all right? Now, what do we have over here with question 2, right? So a gentleman decided to treat a few friends in the following manner, a few children in the following manner. He gives half of his total stock of toffees and one extra to the first child. I have some amount. I'm giving half of it and one more. Okay, done. And then I'm giving half of the remaining stock along with one extra to the second, and continues giving away in this fashion. His total stock exhausts after he takes care of 5 children. How many toffees were there in his stock initially, right? In the stock, how many were there initially? This is not like your usual stuff, because you don't have two variables or three variables, you have only one variable. So what is being told to me over here is, let's say there are n toffees. Now from these n toffees, I'm going to give away half, so I'm left with half, and then I'm going to be giving away one more, right? I'm left with n by 2 minus 1. If I started with n, I'm giving half to the first kid plus 1. So I'm left with the half and minus 1, minus, because 1 has gone away. Now what is going to happen over here? I'm again going to give away half from this. So I'm left with only half. And then I have to give away one more. Okay. After the second kid is done, this is what is remaining, right? Every time. Then what am I going to do the next time? And to this, I'm going to again give away half. So I'm left with half. And then I have to subtract a 1. And this process goes on 5 times, and I have to write equal to 0 and then start moving one after the other, right? One after the other over here. How do I solve for this, right? So one way is to go the painful route and write down half and then a minus 1. And once again, you'll write a half and then a minus 1 over here. And 5 times. So 5 times it got halved. So no mistake over here, 5 children. And you're finally left with 0 because the stock exhausts, right? How do we solve for this? Move this 1 here and then take the 2 there, right? And what do we get? 2. After I move the 1 there and take the 2. And if I have 2, what's going to happen again? I'm going to move the minus 1 and then I take the 2, right? So I'm going to add 1 and then multiply with 2. And what am I getting? 3 into 2, 6. I'm done with the next set as well. No step marks over here. You can't be writing it completely. Each step and all, the exam will be over by then, right? So then move 1 again and then move the 2. And we're going to be getting something like 14. And we are done with the next as well. And then I move 1 again, plus 1. And then into 2. That's when we are moving this and this. And we are getting 30, right? 30 over here. Once again to 30, if you're going to add a 1, it becomes 31 and then multiply with 2 and you get 62. And that becomes the answer over here. This is using an equation, right? An equation format. Is this the most recommended? No, but push comes to shove. If you have to do it this way, you could probably solve it this way, right? But what I would recommend is, if you could just logically look at it, what's happening over here? I'm left with 0 after certain operations, and what is happening at each step? Half is going away and one more, right? And I'm left with something. Half is going away and one more, and I'm left with something. Now, what happened in the last step? How did it become 0? I gave half, and then I was left with only 1, and that 1 was also given away. I'm left with 0. So how do I start recreating it? How do I start recreating it? To the 0, I'm going to add 1, and then I'm putting 1 back because 1 was taken away, right? So I'm going to put that 1 back, and then I'm going to double it. I'm going to double it, right? So from 0, if I'm going to build my way back up, right? So what is going to happen? Now let me write it from bottom to top so that, it's visually fine for you, right? So 0 was what I was left with. I'm going to add back the last toffee, which is given to the last person, and then I'm going to double it, and I'm getting 2. 2 is what I had before I distribute it to the last person, right? So to the fifth person. So that means what happened? This 2 toffees was after I'd given out that 1. So add back a 1 and into 2. What is happening? So I was left with 2 toffees after I gave half and 1 more to the fourth person. So I'm going to add back a 1 and multiply with 2. That's the operation. So I'm going to add back 1 and multiply with 2. So that's going to be a 3 into 2, 6. Now 6 plus 1 into 2, right? So that's going to give me a 7 into 2, 14. 14 plus 1 into 2, right? So if this strikes and this strikes, it's just going to be a pretty quick affair for you to get the answer. This will be a little quicker rather than drawing all of this, writing all of this in going in for these values, knocking off one after the other. How am I recreating my initial pile or pool? I'm going to add back a 1 and multiply it with 2 and double it. Add back 1. Instead of halving and subtracting 1 from the top, I'm halving it and subtracting 1, halving it and subtracting 1 and getting to 0. What are the opposite of half and minus 1? What's the opposite of half and minus 1? A plus 1 and doubling, right? Doubling over here. So plus 1 and doubling is what I'm going to be doing. 0, add 1 and double, add 1 and double, and you continue and go backwards. This is when you're coming from top to bottom. This is when you're going from bottom to top. Next one, right? So on to question 3. A basket of 2 apples, 4 oranges, and 6 mangoes costs the same as, same means equal to symbol, as a basket of 1 apple, 4 oranges, and 8 mangoes. Okay. What do I observe with these two? 4 oranges here, 4 oranges here. If I equate these two, I can find the ratio of the cost of an apple to a mango. Okay. Or a basket of 8 oranges and 7 mangoes. Okay. Fine. So let's do it, right? It's just saying, all of these are going to be equal. Let's call this R, let's call this M, and let's call this A. So 2A plus 3R plus 6M, 4R over here, plus 6M equals A plus 4R plus 8M, right? And what am I finally required to find? The number of mangoes in a basket of mangoes that has the same cost as these. Okay, let's call this basket with equal costs, right? Basket over here. And there's a third basket over here, which has 8R plus 7M. Okay, I need to find out how many M over here, right? How many M over here is going to be equal to each of these. That's it. If I write R in terms of M, that itself is enough for me, right? And what can I do over here with the first and second over here? 4R and 4R are common. So if I equate these two alone, I'm getting 2A. I mean, if I cancel these two alone, I'm going to get 2A plus 6M equals A plus 8M, right? And I bring the A here. A equals, take the 6M there, I'm going to get 2M. That's it. A equals 2M. Now, A equals 2M, I can now substitute into this. And what do I get over there? I'm going to get 2M plus 4R plus 8M. That is 4R plus 10M equals whatever I have over here, 8R plus 7M. So if I bring the R here, I'm going to get 4R equals, take the 7M, and I'm getting 3M. That's it. 4R equals 3M. If 4R equals 3M, then how much is 8R going to be? Double of this, 6M. That's it. So if 8R equals 6M, I can replace this with 6M. And I say 6 mangoes along with 7 mangoes, a total of 13 mangoes. 13 mangoes cost price is going to be the same as this, and so on. So 13 becomes the answer over here, right? Where A, R, and M are nothing but the cost of 1 mango, 1 orange, and 1 mango, 1 orange, and 1 apple for M, R, and A, right? So that's something I didn't mention at the start, right? Yeah, so those are the variables, and this is how we do it, right? So this is the cost of a basket. So on to question 4. The amount Neeta and Geeta together earn in a day equals what Sita alone earns in 6 days. The amount Sita and Neeta together earn in a day equals what Geeta alone earns in 2 days. Okay, the ratio of the daily earnings of the one who earns the most to that of the one who earns the least over here. So clearly in this case over here, we having only 2 equations, but we have 3 people, 3 variables over here, right? 2 equations, 3 variables. Like in the previous question, we will not be able to solve for the value of each of them, but I can find the ratio of each of them, right? Ratio of the variables, because there is no constant involved, right? Let's look at it. The amount Neeta and Geeta earn in a day, let's call that N and G. So N plus G equals 6 days whatever Sita earns, right? 6S. So NGS are the amounts that Neeta, Geeta, and Sita earn in one day, right? 6 days whatever Sita earns. equals n plus g. The next equation over here, the amount Sita and Nita together earn in a day. So S plus n equals what Geeta alone earns in 2 days. So 2g over here, right? So how do we solve for this and find the ratio? And what do I need to find the ratio? The ratio of the one who earns the most to that of the one who earns the least. So n equals 2g minus s, right? So n equals 2g minus s. Once again, why would we be able to find the ratios? Three variables, only two equations, but we'll be able to find only because there is no constant term. The moment I add a plus 5 or something, we won't be able to solve for it. We won't be able to find, right? So n equations, n minus 1 variables, one less, the ratio can be found over here if there is no constant. So if n is 2g minus s, and we plug this in over here into this one, then 2g minus s plus g is 3g minus s equals 6s. So 3g equals 7s, and g by s equals 7 by 3. G by s equals 7 by 3. At this stage, some of you would be wondering, how do I substitute g equals 7s by 3 and all of that? Don't need to do that. Just create a variable x, right? If g is 7x, s is 3x. Now 7x and 3x we can plug in over here, any of these. Let's say into this particular equation, or rather we have n equals something. So n equals 2 times g, 2 times 7x, which is 14x, minus a s over here, which is 3x, and I'm getting 11x over here. So what is the ratio of n is to g is to s? That's going to be 11x is to 7x is to 3x over here. X's are cancelled, so I'm not writing it down. So 11 is to 7 is to 3. What is the ratio of the daily earnings of the one who earns the most to that of the one who earns the least, right? Which is 11 is to 3. So option 3 over here becomes the answer. So next one, question 5, slightly longer one, right? So what do we have? A tea shop offers a tea in cups of 3 different sizes. The product of the prices in INR of 3 different sizes is equal to 800, right? The product of the prices for these 3 sizes is 800. The smallest and the medium size are in the ratio 2 is to 5, right? So you have small, medium, and you're going to have large, right? And small and medium are told that, we're told that the prices of these, the prices over here is in the ratio of 2 is to 5. So I can call it 2x and 5x, right? For small and medium. If the shop owner decides to increase the price of the smallest and the medium ones by INR 6, keeping the price of the largest size unchanged. Let's keep that as y. The y is unchanged. The product then changes to 3,200, right? So that means 2x into 5x into y is given to us as 800. And we have a 2x plus 6 into 5x plus 6, right? Both of those, we're going to be increasing it by 6 rupees into y over here is going to give us 3,200. The sum of the original prices of 3 different sizes, that is 2x plus 5x plus y. I have to add those up and see what I'm going to get over here, right? So how do we solve for this? Several ways of doing it, right? But we know that it's going to be an integer answer. The standard method, let's just do that first, right? So we divide these two equations, bottom by top. We're going to get 2x plus 6 into 5x plus 6 divided by 2x into 5x. Okay, so 2x into 5x is, just write that down, 2x into 5x equals what? Equals 4 by 1, 4. One way to do this is simply going to, actually we can just cross multiply. 2x into 5x is 10x square is going to get cancelled over here, right? So we get a 10x square plus 6 into 5, 30, 6 into 12. So that's going to be 42x plus 6, 6 are 36 equals, actually it's 4 into, right? So it's not going to get cancelled. So 4 into 10x square is going to be 40x square, and we get 30x square. We can divide, yeah, so 30x square minus 42x minus 36 equals 0. We can divide all of this by 30 and we're getting 5x square minus 7, by 6. So we get 5 square minus 7x minus 6 equals 0. Now 5 into minus 6, product is minus 30. The sum over here is minus 7. 10 into 3 is 30, the difference being 7, right? So therefore, the x values over here, if I have to directly find x values over here, I have to first write 10 over here, all right? Sorry, minus 10 it is, minus 10 and a plus 3 is what is going to add up to minus 7. Um, switch the signs, we'll be seeing this in quadratic equations, and then divide by the coefficient of x square over here, which is 5. Your price cannot be negative, so ignore. 10 by 5 is the value, so that is 2. 2 2s are 4, 5 2s are 10. Now, if this is 4 into 10, right? 4 into 10 over here. 4 into 10 is 40. 40 into what over here is going to give me 800. That is 20, right? So this becomes 20. So the answer is 4 plus 10 plus 20. The sum of the original prices, that comes to 34. So let's move to the sixth question. A shop owner bought a total of 64 shirts from a wholesale market that came in two sizes, small and large. The price of a small shirt was 50 rupees less than that of a large shirt. Okay. She paid a total of 5,000 for the large shirts and a total of rupees 1,800 for the small shirts. Then the price of a large shirt and a small shirt together is what? It's a simple linear equation question, right? But what are the variables over here, right? A total of 64 shirts were bought in two sizes, small and large. So you can just write down small and large over here from a reference perspective. The number of shirts over here purchased is going to be, let this be S. This is going to be 64 minus S, or S might be a little confusing. Let's just write it clearly. Let's make it X over here and 64 minus X, right? And what about the price of a small shirt was 50 less than that of a large shirt. So if this is going to be y and this is y minus 50, let's write it the other way around. If this is y, this is going to be y plus 50. Right? So if this is y, this is going to be y plus 50. Then what is going to be the price of a large shirt and small shirt together? The price of a large and small together, I need to find 2y plus 50. Right? Which of these is going to be equal to 2y plus 50? So two ways to do this. One is to completely solve for this. Given that the other is, given that options are there, I might want to substitute, right? So first up, let's multiply and write down whatever we have. X into y over here equals, right? For the small shirts, you paid 1,800, right? And here 64 minus x into y plus 50, right? I'll just write that down a little lower, right? 64 minus x into y plus 50 over here is coming to 5,000, right? 5,000. So now, if 2y plus 50 is this, that means if I subtract 50, I would want to start off with a 2 multiple. Where do I subtract 50 and get a 2 multiple? Over here at 150 and 200. So if 2y plus 50 is 150, then y is going to be, 2y is going to be 100, y becomes 50. The next one, if 2y plus 50 is 200, then y becomes 75. Between these two values, I might want to go for 50 first and see as to what I'm getting. It might make my life a little easy. So if y is going to be 50, 1,800 by 50 is 180 by 5, which comes to 36, right? Then if I'm going to get 36 as x, 64 minus 36 is coming to 28. And here I'm getting 150, right? At this stage, we can say that, it doesn't seem like it's working out for us. The reason being, I don't have a 7 multiple in 5,000. 28 is 4 into 7, integer value. So this is definitely not the answer. Y equals 50 is not working out. Next, try out a y equals 75 and see if it's working out. If y is 75, 1,800 by 75. So first I'll divide a 3. It comes to 600 by 25. 600 by 25 is 6 into 4. 24 we get as x value. right? And now see if we're getting 5,000 over here. It's 24 and I remove a 24 from this, I'm getting 40. And if I have to add a 50 to 75, I'm getting 125. And 40 into 124 into 125 is 500. 5,000 is what I'm getting over here. This is correct. Y equals 75 is correct. Option 4 I mark and keep going. So next up, we'll take up some simple equations with inequalities, which has been coming up in exams, right? So where we need to find the maximum and minimum. Um, Quite a few questions have turned up, right? So I have about 6 questions under this, and let's look at the first one here, right? So what do we have? X and Y are non-negative integers. That means x comma y are greater than equal to 0, non-negative. It cannot be negative, it can be 0 or more. We need to be very clear with these terms. Such that x plus 9 equals z, y plus 1 equals z, and x plus y is less than z plus 5. Then the maximum possible value of 2x plus y. 2x plus y over here, I have to maximize, right? So simple maximum minimum. If I have to maximize 2x plus y, I have to maximize 2x and y, right? Maximum possible values for these. And with this one single inequality, simple inequality given over here, how do we do this? X is equal to z minus 9, right? I'll substitute z minus 9. If x plus 9 is z, x is z minus 9, skipping some steps here. And and what is going to be y over here? Plus y plus 1 is z, so then y is going to be z minus 1 plus z minus 1 is going to be less than z plus 5, right? So 2z minus z is giving me a z. Minus 9 minus 1 is a minus 10. Minus 10 I can take to the other side. I'm going to get a plus 10, right? So I'm going to get a 15 over here. Z has to be less than 15. Z has to be less than 15, and x over here is equal to, what do we get? Z minus 9, and y over here is going to be z minus 1. Z has to be less than 15. X and y are integers. I have to maximize them. What's the maximum I can give for each of these? The maximum I can give for each of these is going to be when z is going to be maximum, right? Higher the value of z, higher the value of x for me. So what is the maximum value I can have for z? Z has to be less than 15. 14 is what I can give in for z. And 14 minus 9 is 5. 14 minus 1 is going to be 13, right? So 2 into 5 plus 13 is the answer. So that's 10 plus 13, 23. 23 is the answer for this question. So let's look at the next question over here. Question 8. The arithmetic mean of x, y, and z is 80. One equation, 3 variables, fine. That of x, y, z, u, and v is 75. Okay, now 5 variables are brought in. Then u is x plus y by 2, v is y plus z by 2. I have 4 equations now, totally 1, 2, 3, and 4. And they've said x is greater than equal to z. Then minimum possible value of x is what? I can't solve for all of them because I have one equation less, 5 variables, 4 equations, 1 inequality. Then I can go for the minimum, maximum, all of that. Let's see how. The moment I know arithmetic mean is this, then what is the total going to be? Total is going to be average into number of terms, 80 into number of terms 3, right? So instead of writing x plus y plus z by 3 equals 80, and then writing the next step is x plus y plus z equals 240, don't waste time with all of that. Directly write x plus y plus z equals 80 into number of terms, that is 3, so 240. Next one, 5 terms, average is 75. So x plus y plus z plus u plus v equals 5 into 75, right? 5 into 75 is the total, 375. So we get 375 over here. Now immediately, bottom minus top, x, y, z get cancelled, and I get u plus v over here equals 375 minus 240, which is 135. So I'm now reduced to two equations over here. Using this, I'm getting u plus v equals 135, and x plus y plus z is 240. Okay. So now where u is x plus y by 2 and v is y plus z by 2, okay, then the minimum possible value of x is what? Let me just substitute these two over here and see what we are getting, right? U is x plus y by 2. So x plus y by 2 plus v is y plus z by 2. Y plus z by 2 equals 135. The 2 LCM is the same. So take the 2 and multiply there, you get a 270. And what do we get here? X plus 2y plus z. X plus 2y plus z. So x plus 2y plus z is 270. X plus y plus z is 240. Let me write that down over here. X plus y plus z is 240. Then what can I do? If I top minus bottom, right? If I subtract x and z are getting cancelled, I get y equals the middle term over here. Y equals 270 minus 240, which is 30. So y is found. Now, when you have 4 equations and 5 variables, I'm not saying you can't solve for any variable. You might be able to solve for 1 or 2 of them, but not all 5 of them. So this is one such where the middle way, I mean, y variable, we are able to solve for and find the value as 30. If I plug it in over here, what am I getting? X plus z equals 210. Y is 30. 30 I take to the other side. I'm getting x plus z equals 210. When I'm given this inequality, x is greater than equal to z, and I have this with me, I'm feeling a little better because this inequality can be used in this particular linear equation to find the minimum possible value of x. Which is bigger between x and z? X has to be greater or equal to z. Greater than or equal to z. So therefore, for me to find the minimum possible value of x, if I have to find the smallest over here, sum is constant, the other variable should be largest possible. What is the smallest I can bring x to? X I can bring smallest to when it's equal to z. If x equals z, then that's going to be the smallest value of x. When x equals z, I'm bringing it to 105 and 105. How? X plus z, both are equal, equals 210, half of each, half to each. So this is where it becomes equal. If I increase x to 106, this becomes 104. It satisfies, correct? But I want the minimum possible value, and the minimum is at 105 and not 106 or anything more. So 105 over here becomes the answer for this question. So the next question over here, question 9. Aaron bought some pencils and sharpeners, spending the same amount of money as Aaron. Aditya bought twice as many pencils and 10 less sharpeners, right? If the cost of one sharpener is 2 more than the cost of a pencil, then the minimum possible number of pencils bought by Aaron and Aditya is what? We're supposed to write let something be the price of and all. It's going to be painful. So what we'll do is we'll form a table for our steps over here, all right? I mean, a table for understanding what variables we're taking for what. So let's say Aaron over here and Aditya. And what are we going to have in terms of yeah, so the number of oh, we have pencils and sharpeners over here, right? So the number of pencils and sharpeners, okay. And yeah, so let's do that. Number of pencils, number of sharpeners, and we have the price as well, right? Okay. The price of a pencil and sharpener over here is going to be P and S. That's it, right? P and S. So let the number of pencils over here bought by Aaron be X. Then Aditya bought twice as many pencils. Okay, that's going to be 2x. And what about sharpeners? Sharpeners, Aaron bought S. Sorry, S has been used. So Y over here. And this over here is going to be number of sharpeners is going to be Y minus 10, right? Y minus 10. But these two are going to be linked up over here. Pencils and sharpeners are linked up, and how are they linked up? Cost of one sharpener is 2 more than the cost of pencil. Cost of one sharpener is 2 more than that of a pencil. So P and P plus 2 are the costs of a pencil and a sharpener, right? So now what are we told? They spent the same amount of money, both of them, for purchasing these, right? Um, Now, if this is the case, the minimum possible number of pencils bought by Aaron and Aditya together is what? Total pencils bought by the two of them is 3x, right? So 3x over here, total. And that is what I have to minimize. Minimize. What is the smallest possible value of 3x, right? So how do we find that? Let's see. So p and p plus 2 over here, and any other condition they've given us, anything on integer and all of that, no. The numbers are going to be in integers, and I think that is all we know over here. So the number of pencils is x over here for Aaron. Cost of a pencil is p, so that's going to be px, right? Amount spent, right? Amount spent by Aaron over here is px for pencils, and p plus 2 into y over here for sharpness, p plus 2 into y, and this is equal to whatever was spent by the other person, right? Who's Aditya. Now Aditya is 2x into p, 2px plus p plus 2 into y minus 10, right? P plus 2 into y minus 10 over here, okay? And then we can, so then we can just multiply these, I think. So px plus py plus 2y over here equals 2px plus py minus 10, I mean plus 2y minus 10p, and then we have a minus 20. Let's cancel whatever we can, right? 2y gets cancelled over here, and the px, I take it over there. I'm going to get 1px equals, bring the 10p and 20 over here, 10p plus 20, right? So 10 times p plus 2 over here is going to give us px, right? Px, and yeah, so there was a slight mistake there. So 10 times p plus 2 is px over here. So what can I say about x over here? X is going to be an integer, number of pencils over here, right? So x has to be an integer. So therefore what I can do is x equals 10 times p plus 2 divided by p, right? 10 times p plus 2 divided by p over here, which means now if I have to minimize this number, I have to put what should p be over here? Should it be the smallest value or the largest value, right? So to get that, you can just look at this as 10 times p plus 2 by p, which is nothing but 1 plus 2 by p, right? So 1 plus 2 by p, that's going to be the x value. Keeping the 10 over here, divide individually, 10 times 1 plus 2 by p. Now, if I want to reduce the value of x, right? If 3x has to be minimized, x has to be minimized as well. Okay, so the issue over here is, if you're going to be writing as 10 into 1 plus 2 by p and maximize p, we're going to get a value of p equals 2, right? This is the mistake over here. We can't be looking at it this way. So far, everything is fine. We just have to multiply and look at it, right? Why? Because this 10 over here can be, I mean, p over here can be divisible by this as well, right? So let's multiply and see as to what we are getting. P equals 10 plus, now we are getting a 20 by p, right? So 20 by p. Now we have to do this, right? We can't have a 10 common and then look to apply it. Then we have to multiply 10 plus 20 by p. If x has to be minimized, p has to be maximized. What is the largest value p can take so that x is going to be an integer? The largest value p can take over here is, for it to be divisible by 20, is going to be 20 itself. Then 20 by 20 is 1, and we're getting 10 plus 1, 11. Anything smaller than 20, we're going to get a bigger value, 10 plus a bigger value. We don't want that. X has to be an integer, which means p should divide 20 perfectly and should be as big as possible, should be 20 itself, right? So 11 is what we get as the value of x, and 11 3s are 3x is what we have to find. So 3x becomes 3 into 11, which becomes 33, right? So option 4 becomes the answer, right? So we have to look out for this 10 over here. Took it common, which is fine. Then we have to multiply it back and then look at the minimum possible value of x. So the next question over here, right? So where we have something to do with n, x, and y. Again, 3 variables over here, and we have an equation defining n as sum of x and y, and we are told that all of them are positive integers. They are all greater than 0, 1 or more. And I have a range for x, 2 is less than x is less than 10, and for y is 14 is less than y is less than 23, and I'm told n is greater than 25. N is what? Sum of these two should be greater than 25. Then how many distinct values are possible for n? What are the different possible values for x and y? No, 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 no. I'm asked what are the different possible values of n? What are the different values n can take, right? For these inequalities over here, what are the different values n can take if n is greater than 25? What is the maximum value x can, let's find the maximum possible value of n. What's the maximum value n can take when x and y are going to be maximized? When x is maximum and y is maximum. The largest value x can take over here is 9. The largest value y can take over here is 22, right? One less than that. So 9 plus 22 is 31. So largest possible value of n is 31. Now, what are the how many distinct different values n can take? I'm not bothered about x and y. So can n take a value of 30, one less than that? Yeah, so if I reduce 1 over here and I make it 8 plus 22, that's also in the acceptable range. 30 is possible. And if I keep reducing, what is the lower limit? N has to be greater than 25. 25 is not allowed. 26 is allowed. 27, 28, 29, 30, and 31. 6 possible values. 6 becomes the answer. In case you're wondering whether 26 is possible, look at the lower limit. 15 and 3 over here. 15 plus 3, 18. So n over here, you can just looking at the lower and the upper limits. The lowest possible value is 18, right? 3 and 15 over here, x and y values. Largest possible values are 9 and 22. 9 and 22, if you're going to add up, it's going to be 31. The range of it is going to be 18 to 31. All possible values from 18 to 31, the integers. N is greater than 25 is qualified, so it's only 6. Now, if you typically what they'll ask in these questions is how many x comma y ordered pair values satisfy and all of that. We have to read the question carefully. That's not what is asked. How many distinct values are possible for n? 26 to 31. That's it. So what do we have over here? So question 11. So we have three positive integers x, y, and z are in arithmetic progression. If y minus x is greater than 2, y minus x over here is greater than 2, and xyz equals 5 times x plus y plus z, also given. Then z minus x equals what? All right. So arithmetic progression with three terms over here. Let's go with a minus d, a, and a plus d. Right. The middle term is going to be a. One is d less and one is d more. The reason why we take it this way is because I have x, y, and z multiplied over here. And when x, y, z are getting added over here, all the d's get cancelled, right? So this is an easier way to represent this. But what am I told over here? Y minus x is greater than 2. What is y minus x? The common difference. The common difference of d is greater than 2, right? Has to take a minimum value of 3 or more because they're all positive integers. If all of them are positive integers, d is getting added, it still remains a positive integer, right? So d is therefore going to be a integer over here. Yeah. So what do we have over here? X, Y, Z equals 5 times x plus y plus z, right? So x, y, z over here is going to be product of these a minus d into a plus d. I can write that as the middle term into a minus d into a plus d, which is a square minus d square. Okay, so that is x, y, z, okay, equals 5 times x plus y plus z, 5 times x plus y plus z, x plus y plus z, d and d are cancelled, 3a into 5 is going to come to 15a. A can be cancelled on both sides. A square minus d square is 15. A square minus d square is 15. I can in fact write it as a plus d into a minus d itself right now and say that that is equal to 15 over here. Now, how do I find, what do I need to find? I need to find z minus x. There is one inequality given over here, which is the common difference. D is going to be greater than 2. D is going to be greater than 2. I know that A and D both have to be integers because all of them are integers. So A is definitely an integer. Whatever I'm subtracting from that integer should also be an integer, right? So therefore, both A and D are integers. Product of two, so A plus D and A minus D are also integers. Product of two of them is coming to 15, right? So 15, I can write it as 1 into 15, or I can write it as 3 into 5, right? So A plus D and A minus D, this is the bigger term. So if A plus D is 15 and A minus D is 1, or I can have A plus D is 5 and a minus d as 3. Only then both a and d are integers, integer into integers, another integer. So if a plus d is 15 and a minus d is 1, if I add the two of them, 2a equals 16, a equals 8, and if I substitute here, d is going to be coming to 7. Does this satisfy d is greater than 2? Yes. The next one, if a plus d is 5, I'll write that down. I'll write that down here itself. A plus d is 5 and a minus d is 3. Then 2a equals 8 and a equals 4. And d over here is going to be what? 4 minus what is 3? 4 minus 1. D equals 1. Does it satisfy this? D is greater than 2? No. So therefore, it has to be the first one. What is asked is z minus x. What is z minus x? 2d, 2 times d, the common difference. So 2 times common difference is nothing but 14. So option 4 becomes the answer here. So question 12, a donation box can receive only checks of 100 rupees, 250 rupees or 500 rupees on one good day. The donation box was found to contain exactly 100 checks, amounting to a total sum of 15,250. Okay. Let A be the number of checks for 100 rupees, B for 250 and C for 500. I have two equations over here. One is A plus B plus C. Total number of checks is 100. Then I have one more equation over here which says 100A plus 250B plus 500C equals 15,250 rupees. What is definitely divisible by all of them? 50 is divisible by all of them. If I divide by a 50, I'm going to get 2A plus a 5B plus a 10C equals, if I have to divide this by 50, 15,000 divided by 50 first is 1,500 by 5, which is 300. 305 is what I get over here, right? So 2A plus 5B plus 10C is 305. I shall write that down over here. 5B plus 10C is 305. Now what is asked? Then the maximum possible number of checks of 500 rupees, which is C, has to be maximized. I have to maximize C. So I have to get rid of one of the variables, right? One of the variables I have to get rid of. The easiest and quickest I can get rid of is going to be A, right? So this into 2, bottom minus top, 2A minus 2A is 0, 5B minus 2B is 3B, 10C minus 2C is 8C equals 305 minus 200 is going to be 105, right? So this is what we get over here. C has to be maximized. So C is going to be 105 minus 3B divided by 8 over here, right? 105 minus 3B by 8. I subtract a 3B, it should be divisible by 8, right? Now C over here has to be maximum possible, right? C has to be the maximum possible number. So whatever is being subtracted has to be smallest possible. Now B over here, what's the smallest value it can take? It can take 0. If I put 0, 105 is divisible by 8? No. If I put B is equal to 1, so B is equal to 1, then I'm getting 105 minus 3, 102 by 8. Is that divisible? Again, 102 is not even a 4 multiple, not happening. B equals 2, I'm going to skip because I'm subtracting one more 3, it's 99. So I'll try a B equals 3 over here. If B is 3, 3 3s are 9. 9 I'm subtracting from 105, it's going to come to a 96 divided by 8, perfectly divisible. If B is going to be 3, C is coming to a value of 96 by 8, which is 12. And that's the largest possible value C can take. So let's look at the next one, age-based questions, right? So you can either use tables and fill that up with variables, right? We've seen that in other averages and other kinds of questions, right? The average age of two people and all of that. Always use A and B. It can be present minus 6 years. We need to find present minus plus 10, 10 years after, 10 years from now and all of that. Use one variable. If 6 years back, A was twice as old as B, 2x and x. Present is going to be 6 years later, 2x plus 6, x plus 6, and some relationship might be given here, right? So just look to form this table and use a variable, a single variable to represent, right? So that would be one of the better ways to solve these. The one on ages which I could find was this, right? 2020 slot 3. but this was quite an easy one, right? So what do we have here? Dick is thrice as old as Tom and Harry. Tom and Harry is twice as old as Dick, right? So we got to stop over here. And these are two different sentences. So Dick is thrice as old as Tom and Harry. Don't read it that way. Dick is thrice as old as Tom. So D equals 3T. And Harry is twice as old as Dick. So H equals 2D. If H is 2D, D if I substitute, I'm going to get D is 3T. I'm going to get 6T over here. 2 into 3T becomes 6T. If D's age is 1 year less than the average of age of all three, then H's age is how much? So T, D, and H, right? So T is T, and D is going to be 3T, and H is going to be 6T. D's age is 1 less than average of all three, right? So D over here, which is 3T equals, subtract 1 from average of all three. 6 plus 3 plus 1, that's 10. 10T by 3 over here. So what are we getting if we take the LCM and throw the 3 there? It's a 90 equals 10T minus 3, right? 10T minus 3 divided by 3, throw it there, and you get a T equals 3 over here. Harry's age over here is nothing but 6 times 3, which comes to 18. So 18 becomes the answer over here. So the next, typically this concept is covered in numbers as well, right? So if we have a two-digit number, which with xy being the tens in the ones place, the units place, then 10x plus y is the value of the number. The digits are reversed, then the value becomes 10y plus x. If I'm going to subtract, find the difference between these two, it's going to become a 9 multiple. 9 times x minus y and so on, right? If we're going to add the two, it's going to become a 11 multiple. 11x plus 11y. So remember those. But a couple of questions around digits were slightly different, right? So what do we have here? Question 14. While multiplying three real numbers, okay, we have to be careful with all of these, right? Every word matters over here. Ashok took one of the numbers as 73 instead of 37. Okay. As a result, the product went up by 720, right? It went up by 720 over here. Now, if you took 73 instead of 37, one of the numbers I'm increasing it. What is the increase in a number? 73 instead of 37, 73 minus 37, it has gone up by 36, right? The increase between the two is going to be 36, and the two other numbers are going to be A and B, right? You can directly write it this way. Or you can say one of the numbers is 37, then the product should have been 37 into A into B. But what did Ashok end up doing? He took it as 73 and then multiplied with A and B. The difference between these two has come to 720, right? You can either write it this way and then get 36AB equals 720, or you can say the difference in the numbers 36 into A into B. So that resulted in the increase. So the increase by 720 was because of 36 into A into B, right? Both ways we're going to get the same. And we get A into B equals 720 divided by 36, which is 20, which is 20. What is the minimum possible value of the sum of the squares of the other two numbers? So A square plus B square should be minimized, right? Smallest value. The product is constant. The product is constant. I have to find the smallest possible sum of the squares over here. We've actually seen this, this will be covered in greater detail in inequalities lesson, right? So in this scenario, what happens over here is the value should be as close as possible to each other. A equals B. If A and B are as close as possible to each other, then the sum gets maximized, or the sum of the squares gets, sum gets minimized, or some of the squares get minimized. A simple look at it: 1 into 20, 2 into 10, or a 4 into 5, right? As they get closer and closer, your 4 plus 5 was only 9, 2 plus 10 was 12, and 1 plus 20 was 21, right? As they get closer, the sum gets minimized. Sum of squares will also get minimized. So A and B have to be as close as possible to each other. As close as possible looks like 4 and 5, but we need to pay attention to the question. What is being said over here? The three are real numbers. If the three are real numbers, the 73 and 37 were misleading, right? They were integers. The first one was an integer, The other two need not be integers. They have to be real numbers. If both of them are going to be as close as possible, they can be equal. If AB equals 20 and A equals B, then A square equals 20 and A equals root of 20, right? Root of 20 over here, plus or minus root of 20. So if A is plus, can be plus root 20, B can be plus root 20 or the other way around, right? So B equals plus or minus root 20 as well. But I anyway have to be squaring them and then adding them up. What is this? What is root 20 whole square plus root 20 whole square? The value is going to be 20 plus 20 comes to 40. So 40 becomes the answer over here. We have taken 4 and 5. 4 square would have been 16. 5 square is 25. So it'll come to 41. That's not the minimum. The minimum is 40. So question 15 here. In a 6-digit number, big one, 6-digit number, the sixth, that is rightmost digit is the sum of the first 3 digits. The fifth digit is the sum of the first 2 digits. The third digit is equal to the first digit. Okay. The second digit is twice of the first digit. I might want to start with these. The fourth digit is the sum of the fifth and sixth. Okay, so then I'll want to start with these. Third is equal to the first. So first, second, third, fourth, fifth, and sixth. Third is equal to the first. So therefore, I'll go for an A and an A. The second is twice the first. Second is 2 times the first, which is 2A. The fourth is sum of fifth and sixth. So I have to find fifth and sixth first. The sixth is sum of the first 3. A, 2A and A is going to add up to 4A. And the fifth is the sum of the first 2. Fifth is the sum of the first 2, that is 3A. Right. Fourth is sum of fifth and sixth. That's going to be a 7A. Then the largest possible value of the fourth digit. Fourth digit, only one value is possible, where A is 1. If A is 2, then it becomes 14. That's a problem over here. 14 can't be a single digit, right? So A equals 1 is the only number which is going to be satisfying this over here. So we get 121734 is the number, and 7 is the value of the fourth digit. The answer is 7 here. So let's move to the next concept then. So fraction based and exam based questions. Fraction based is typically like, something like A by B could be given, and then A plus 3 by something is something's changing over there. We have to use that. Just go with the flow and you should be getting it. Exam based questions are quite common, right? So we'll take a look at a couple of them. In an examination, drama score was 1/12 of the sum of the scores of Mohan and Anjali. After a review, the score of each of them increased by 6. All 3 of them went up by 6. The revised scores of Anjali and Mohan and Rama were in the ratio of 11:10:3. Okay. Then Anjali's score exceeded Rama's score by how much? Right? Exceeded Rama's score by how much? So in this, the revised scores are what are given, and that can be written in one variable, with one variable 11x, 10x, and 3x over here. And what is that? That's for A, M, and R. What was the initial scores before the review? Right? Initial scores before the review, everybody's was increased by 6 to come to this. Subtract the 6, 11x minus 6, 10x minus 6, and 3x minus 6. And what do I know over here? Rama's score was 1/12 of the sum of scores of Mohan and Anjali initially. 3x minus 6 equals 1/12 of, right? Going forward, you can just multiply this 12 and write it, right? So equals sum of A and M. That's going to be a 21x minus a 12. Throw the 12 here, you're going to get a 36x minus 72 equals 21x minus a 12. Take the 72 there, you're going to be getting a 60. Bring the 21x over here, you're going to get a 15x. So x equals 4. Now what's asked? Anjali's score exceeded Rama's score by how much? In both scenarios, it's going to exceed by 8x. Minus 6 cancelled, it's only 8x. So 8 times 4, right? Anjali minus R is 8x. 8 times 4 over here comes to 32. Option 1 becomes the answer here. On to question 17, right? Something from the slot I written. In an examination, there were 75 questions. 3 marks were awarded for each correct answer, 1 mark was deducted for each wrong answer, and 1 mark was awarded for each unattempted. Unattempted is also getting you a mark. Fine. Ryan scored a total of 97 marks in the examination. If the number of unattempted questions was higher than the number of attempted questions. Okay. So attempted could be correct or wrong, right? We need to remember that sum of the correct or wrong. Okay. Then the maximum number of correct answers that Ryan could have given in the examination is what? If the number of attempted is going to be higher than the number, I mean, unattempted is higher than the attempted. That means let's call it correct, wrong, and unattempted. Let's write down the marks first. +3, -1, and +1 over here. What can I say about the number of unattempted? U should be greater than C plus W is one way to write it. But when I know sum total is completely going to be 75. Now, once again, why is U greater than C plus W? Unattempted is greater than attempted. Attempted can be correct or wrong, both ways. Sum of those two is attempted. U is the unattempted. U has to be greater than this. I can actually write down U has to be greater than 37, right? That is greater than equal to 38, right? Why am I able to do this? 75 is sum total of everything, U, C, and W. 75 is the sum total of U, C, and W. If unattempted has to be more than the others, unattempted should be at least 50% of the paper. Logically, if you look at it, should be more than half of this, 37 and a half, can be 38 or more. But if you really want to strictly follow, this is not going to get you marks in the school exam, right? But if you want to follow something like U plus C plus W equals 75, C plus W equals 75 minus U, and then say U is going to be greater than C plus W is 75 minus U. I can write 75 minus U, bring the U here. 2U is greater than 75. U is greater than 75 by 2, which is 37.5. Lot of steps, but you'll still get the same. U has to be greater than or equal to 38, right? At least half the paper should be unattempted. If unattempted is more than attempted. Makes sense, that bit? Right. So if the number of unattempted is higher than the attempted, then we get U is greater than or equal to 38. Okay. Then the maximum number of correct answers that Ryan could have given in the examination is what? Let me also write down the initial equation, which is U plus C plus W is coming to 75 over here. Okay. Now, if Ryan got 97 marks, right? So 3C minus W plus the U is going to come to 97. And I have a U plus C plus W is 75, right? U plus C plus W, write a plus U plus W and a C over here. That is coming to 75. Now, once again, U is greater than or equal to 38. I need to find the maximum number of corrects. I want to retain the U variable because there's an inequality around that. I want to keep the C variable because correct answers I have to maximize. I have to get rid of this middle variable, which is W over here. Just add the two. What are we getting? We're getting 4C plus 2U equals 97 plus 75 over here, 172. Divide by 2, 2C plus U equals half of this, 86. So C equals 86 minus U divided by 2 over here, right? 86 minus U divided by 2. And I have to look to minimize the value of, so I have to maximize the value of C. Then U should be as small as possible. The smallest value I can use for U over here is 38. U has to be greater than or equal to 38. So therefore, C is going to be 86 minus 38 divided by 2. 86 minus 38 is going to come to 48 by 2, which comes to 24. So therefore, the answer over here is 24. So now on to integer solutions, right? So we have two concepts over here. One is where we're going to have a fraction with a denominator, a variable in the denominator, and we have to see the different values which satisfy. The other is where we're going to have one value increases, the other reduces, and all of that. Let's just take it up with two examples. I mean, both have turned up in CAT, right? We'll take up the first one, slightly smaller these are. Let's live with that. How many different pairs A comma B of positive integers are such that A is less than equal to B and 1 by A plus 1 by B equals 1 by 9, right? So 1 by A plus 1 by B equals 1 by 9. In these scenarios, 1 by A plus 1 by B is 1 by 9. So 1 by A equals 1 by 9 minus 1 by B, which is going to be equal to, take the LCM. So B minus 9 divided by 9B, right? B minus 9 divided by 9B. If 1 by A is equal to this, then A equals how much, right? Reciprocal 9B divided by B minus 9. 9B divided by B minus 9 over here. How do I get rid of the variable in the numerator? Denominator I can't. That I can if I'm going to write it this way. This is equal to 9 times B minus 9 plus a 9, right, divided by B minus 9. So what happens? This is going to become A equals 9 times B minus 9 divided by B minus 9 is 1 plus 9 by B minus 9. And we get this. And what have we seen before? We can't have a constant outside. We have to multiply it inside. So A equals 9 plus 81 into B minus 9. 81 into B minus 9. And what should be greater than what? B should be greater than equal to A has to be smaller than whatever the B values are going to be, right? So B, I would want to put the largest possible values. Now, other thing over here is they're all positive integers, right? So all of them are positive integers. So what can B minus 9 take over here? What is the largest possible integer it can take? It can take 81, right? B minus 9 is 81. It's going to be divisible over here by 81, right? So all the factors of 81 can take. What are the positive integer factors of 81 over here? 81 is 3 power 4. So 1, 3, 3 square 9, 27 and 81, right? These are the values it can take. So B minus 9 is 81. So B becomes 81 plus 9, which is 90. Then A is going to be what? A is going to be 9 plus 81 by 81, which is 9 plus 1, which is 10, right? 10 over here. B minus 9, the next possible value over here is going to be 27. 27 plus 9 is going to give us a 36, okay? And if it was 27, 81 by 27 is going to be a 3. 3 plus 9 is going to give me a 12. And what's happening over here? A is less than equal to B, which is fine. Both are satisfied. Next possible value, 9. I'm going to get a 9 here. B is going to be plus a 9, which is 18. If B minus 9 is 9, then B is 9 plus 9, 18. And if B minus 9 is 9, 81 by 9 is 9. 9 plus 9 is giving me 18 over here. Is this fine? Can A and B be equal? They can be. A is less than or equal to B. Now, this itself should tell us that there are only 3 values which satisfy over here, because as I'm reducing B, A is increasing. So as I'm reducing B, A is, A is increasing over here. So it's going to go past, and therefore, I don't want that, the fourth scenario. So we stop over here. I don't want to put a 3 or 12 over here and then see that 81 by 3 is 27 plus 9 is coming to 36. I don't want this is not allowed because A is more than B. So 3 solutions over here exist, and we can close it out this way. So before we move to the next type, the second type over here, let's quickly look at a summary of that. So if A plus 2B is given to be, let's say 2A plus 3B, for instance, right? 2A plus 3B over here is given to be 100, right? What are the A and B values which are going to satisfy over here? We need one more condition over here to find all the possible solutions of 2A plus 3B equals 100, where A and B are integers and A and B are greater than 0, right? That could be a condition, greater than or greater than equal to 0, or A and B are non-negative integers or positive integers. Let's say positive integers, both are greater than 0. What is the smallest values I can take for A and B? Check if one of them is divisible. Yes, A is divisible. So A of 50 over here gives me a B of 0, because 15 to 2 is 100, the rest should be 0. Satisfies, but are both greater than 0? Nope. I am not happy with this set of values. Now, what are the next set of values which are going to satisfy? A is going to increase with B's coefficient, and b is going to decrease with a's coefficient. But wait, hold on. I want to get into positive zone. So 0, I'm going to increase by 2. 50, I'm going to reduce by 3 and make it 47. 47 2s are 94, 2 3s are 6, adds up to 100, works. But why is it working? Because 47, I mean, the sum is constant. If one goes up, the other has to come down. But hey, I want B to go up. B is at 0 right now. So if B goes up, A has to come down. A will come down by B's coefficient. B will go up by A's coefficient, right? So this is the second type we have seen. So if the values are going to be a difference over here, now what happens over here is the first set of values which satisfy, I would want to take 2 into 50 over here. 100 and B is 0, yes. But next set of values, A is going to go up by B square. If A goes up, then B also has to go up because difference over here is constant. So if I'm going to increase by 3, B will be increased by 2, and 53 and 2 are going to satisfy over here, right? 106 minus 6 is coming to 100. That's the difference between these two. If sum is constant, if one goes up, the other comes down. Difference is constant, one goes up, the other also goes up. And here in these type of questions, we'll be told A and B are going to be less than 100 or something like that. We have to see which one races to or reaches 100 first and then close it out accordingly, right? So that's basically the two approaches. In this, one variable over here is increasing. That's going to be greater than 0. That's fine. The other is going to be reducing. 47 next is going to be 44. Difference of 3. If I keep removing 3s, what's the last? The remainder is going to be 2. 2 to 47 are the acceptable terms because B is definitely going to be positive. It keeps increasing. Now 2 to 47, how many terms are there? It's an AP, arithmetic progression. Last term minus first term divided by common difference of 3 plus a 1, right? So 47 minus 2, 45 by 3, 15 plus 1, 16 values satisfy over here. 16 A comma B solutions exist for this with this condition over here. Question 19 now. The number of pairs of integers of x comma y satisfying x is greater than equal to y is greater than equal to minus 20. Okay, starting from minus 20 now, but x is going to be greater than equal to y. Okay, 2x plus 5y is 99. 2x plus 5y is 99. So fine. So how do we do this, right? So 2x plus 5y is 99. What's going to be the smallest possible value? Y, right? Y has to be the smallest. X has to be a little more than that. So do we do it that way? Yeah. So this makes it a little complicated than normal, right? Two ways to do it. Let's start with the first one right now, right? So the first one right now, which is going to be so y over here, we can write it as 99 minus or the other way around. Sorry, x equals 99 minus 5x. Sorry, 5y divided by 2 because I take the one with the smaller coefficient down below over here, and I'm getting x's value as what? If you so y over here has to be an odd number or even. It has to be odd, right? So y is going to be odd. Then this is going to be divisible by 2, right? What is the smallest odd number which y can take? Smallest odd number is going to be minus 19. So y can take minus 19, and what happens to x over here? If y is going to be minus 19, then we are getting plus 95. 99 plus 95 is 194. 194 by 2 comes to 97 over here, right? So 97 over here. A quick check. 2 into 97. Yes, it's 194 and minus a 95, and that comes to 99, right? It all adds up properly. Now, what are we told over here? X has to be greater than equal to y, and 97, I'm going to keep subtracting what? From 97, this satisfies. From 97, I'm going to keep subtracting y's coefficient over here, right? And y is going to be added by x's coefficient. So how many times can I subtract y's coefficient of 5? Let's say k times I'm subtracting, right? K times I'm subtracting, I'm going to get 97 minus 5k. And to minus 19, I'm going to be adding the coefficient of x k number of times. And I get this value, right? This is the last such value which is going to satisfy. After this, it's going to be the other way around, which means x is going to be greater than or equal to this y, right? That's the condition. It continues this way till the last possible value. After that, it doesn't. So how many k's can I subtract over here, right? How many k's can I subtract? What is the maximum possible value for k? That let's find over here, right? So 97 minus 5k is greater than or equal to minus 19 plus 2k. So 97, bring the 19 here, plus 19 is greater than or equal to, take the 5k there, we're going to get a 7k. So k is going to be less than or equal to 97 plus 19, which is 100 plus 14, 100 plus 16, that's a 116 by 7. So k is going to be less than or equal to 119 by 7 is 17. So this is a 16 point something, right? 16 point something. Yeah, 16 point something. K can take all values from 0 to 16. Why am I saying 0? If k is not being subtracted at all, we're getting 97 and minus 19, which is perfectly fine. K can take values from 0 to 16. So 16 times we can subtract from this and get to this point. So total of 17 values, right? 0 to 16, both inclusive is 16 minus 0 plus 1, which comes to 17 over here. That looks complicated, but no, yeah. So if we get a hang of, where to start, smaller coefficient we move to that side, and smallest value we can have over here, it just is going to be a flow after a point. So this is a question which is there in my slot, and this is the one where I actually made a silly mistake towards the end, right, while rushing. But yeah, it's quite a simple question, right? These are questions you should do. So question 20, if a and b are non-negative real numbers such that a plus 2b is 6, a plus 2b is 6, then the average of the maximum and minimum possible values of a plus b, right? A plus b has to be maximum possible value. I have to find what's the maximum possible value and the minimum possible value of this, right? So it's going to be the two edge cases, right? So if you understand a plus 2b is 6, what's the largest value a can take? That's going to be 6. Then b becomes 0. And what's the smallest value a can take? It can take 0. It's non-negative real. If a is 0, then b becomes 2b is 6, so b becomes 3. First case, we get the maximum possible value, which is 6, a plus b. Second case, we get the minimum possible value, which is 3 over here. Typically, we are asked the difference between maximum and minimum. This question, they asked us for average of maximum and minimum. And the difference of these two is also given over here as 3. Average of maximum and minimum is asked. 6 plus 3 by 2 is what we need to find. And that comes to 4.5, right? Option 3 becomes the answer over here. So next up, something like this, I haven't seen the recent past, right? So slightly dated question, but questions like these keep coming up here. You have to be ready for it. 2 equations, 3 variables. We are asked for a dependent equation or something which we can derive using the first 2 equations, right? What do we have here? 3 burgers, 7 shakes, and 1 order of fries. 3b plus 7s plus 1f equals 120 exactly. And at the same time, it would cost 164.5 for 4 burgers plus 10s plus 1f again. I need to find the cost of an ordinary meal of 1 burger, 1 shake, and 1 fries. So b plus s plus f. I want f. I mean, if I subtract, I'm getting a b, but this is 3s and no, it's cancelled out. I don't want that. I want 1b, 1s, 1f, right? What can help me with this? 10 and 7. 7 2s are 14. That's not 7 3s are 21. 2 10s are 20. That might ring a bell for you, right? That might help. So take the large values and see as to what you're getting. The difference should be 1. At 10, you're getting a 14. 7 or 14 doesn't help. At 20, you're getting a 21. That could be the clue. Into 3, into 2, right? I think it works out. 3 3s are 9, 2 4s are 8. Difference is 1. 3 7s are 21, 2 10s are 20. Difference is 1. 3 1s are 3 and 2 1s are 2. 3 minus 2 is 1. So 360 minus 2 times this That's going to be a 329, and that therefore comes to 31. Option 1 becomes the answer over here. The next concept over here is a rupee and paise transposed, right? So I have two questions over here. Both of those we'll see as to how to solve, all right? Question 22 first, right? So we have, so these type of questions where a man receives a check, the amount of rupees has been transposed for paise and vice versa, right? So after spending 5 rupees and 42 paise, he discovered he now had exactly 6 times the value of the correct check amount, right? So what is this question about, right? How does that work over here? So you could get a check for rupees X, and paise could be Y, right? That could be it. But the person at the bank is actually giving it after switching it up, right? Switching it up. What is being given out instead is rupees Y, and the paise given out is X, right? So what is the relationship between rupee and paise? 1 rupee is 100 paise, right? What should have been as 100x plus y has been given out as 100y plus x. That is what has happened. Amount in rupee has been transposed for paise. Now from this 100y plus x, this is what ended up happening. 5 rupees and 42 paise is going to be 542, right? In paise, I'm writing everything in paise terms. 542 was spent, and he discovered he now had exactly 6 times the value of the correct check amount. The correct check amount in paise, I'm writing in the reduced form. Paise is the smallest denomination. 6 into 100x plus 5, 6 times the original value is going to be whatever the transpose minus 542 after spending 542 paise. So now the question is, um, what amount he should have received, right? We have to find the x and y values and find out which is the answer. But if you have options over here, the best thing is to substitute and close it out, right? The correct, what amount he should have received, the correct amount. If the correct amount is 530, if he ended up receiving 30.5, right? 30.5 or 0.5 over here. After spending 5.42, am I going to have 6 times 6.44? Does that make sense? 25 point something? No. First option is not working out. What about the second option, 644? If it got reversed, I'm getting 44.06 over here. I'm subtracting a 5.42. And am I going to get something which is 6 times 6.44? Does that make sense? 6 into this. And if I subtract over here, I'm going to be getting 39, and a 38 point something is this. More or less seems okay. 6 or 36 plus something. This seems okay. What about the remaining 60.44? If it's reversed, then the value is actually reducing, right? But the thing is, when it gets transposed, the value goes up, right? So something 6 times something plus extra 5.42. So no. What about the other one? 44.16 doesn't seem to work out, because when I subtract a 5.42 over here, I'm getting 39 or 38 point something. And is that going to be equal to 3 times? I mean, sorry, 6 times 16.44? No, it's not. 6/16 are 96, way beyond that. There's also not the answer. The closest which seems is 6.44. We can mark that and keep going. We don't need to find the exact value. Working with the options itself should help. You don't need to form this equation to close it out over here. If options are there, the best way is to close it out is going to be this. What if you have a question around the same, but it's going to be something like this, right? A confused bank teller transfers the rupees in paise, and he cashed a check for Shailaja, giving her rupees instead of paise and paise instead of rupees. After buying a toffee for 50 paise, Shailaja noticed that she was left with exactly 3 times as the amount on the check. Let the correct amount be x, y, right? Let that be the correct amount. So the correct amount is going to be 100x plus y in paise. The transposed amount, right, is going to be y dot x. So it's 100 y plus x. That's the transposed amount. The transposed was what was given out. From 100 y plus x, 50 was spent, 50 paise, right? Paise was spent. And what Sharja noted was exactly 3 times what 100x, the correct amount was there, right? So what do we get over here? So 100y is over here. We have a 3y. Bring it here. It becomes a 97y. We have a 300x. Take the x there. It becomes a 299x. Right? Yeah. And then we are left with a 50. Write it down as of now this way. And let's look at what is given over here. Right? So Shalja knows that she was left with this. Which of the following is a valid statement about the check amount? What do I know about x and y? X and y both have to be integers, but valid statement about the check amount is the correct check amount, right? And it's all given as between 13 and 14, between 7 and 8, between 22 and 23. How do I find the exact value, right? But this is where we need to understand that if it's going to be between 13 and 14, it should have been 13 point something. I know the x value, I don't know the y value. The next one between 7 and 8, it is 7 point something. I know the x value, I don't know the y value. Same thing over here, 22 point something, 18 point something, and 4 point something. So I have to substitute I can substitute the x values over here and see where I'm getting a 97 multiple, right? 97 multiple. So write it down as y equals 299x, right? Plus a 50 divided by 97, right? Should be divisible by this. Here, if you apply Chinese remainder, you would be able to reduce it to this, which is I just need to look at the remainder. 299 divided by 97 is going to give me a 8 is the remainder. 8x plus 50 divided by 97 over here. Now I can plug in values and see as to whether it's divisible by 97 over here, right? If I take an x value of the smallest of 4 8s are 32, it's not divisible by 97. No. If I take the value as 7 8s are 56, it is not working out over here. If I take the next possible value of 13 over here, 13 8s are 104. 104 plus 50 is 154, not working out. Take the next value 18. 18 8s are, right? So 18 8s are 180 minus 36, 144. 144 plus 50 is 194. 194 is 97 into 2. This works out. 18, if you substitute, it's divisible, right? So therefore, that becomes the answer over here, right? So although this question seems like you have to find x and y by, trial and error and all of that, no. You could still understand that, between 18 and 19 is 18 point something, then start plugging those values in and close it out.